Welcome to our channel Quaint. Today we are going to discuss a fascinating topic. Of course, this is a fascinating topic: the effect of Doppler shift on satellite communication or satellite signals. Okay, you know Doppler effect. In case of the chapter of waves and vibrations, you might have studied this Doppler effect. This is nothing but a shift in the frequency of sound waves due to relative motion between the source of the wave and the observer. So this is what? This is a shift in the frequency. That means frequency changes. Just suppose an ambulance is approaching toward you. So what happens in that case? The siren, if you can hear the siren, then you notice that the pitch of the siren increases as the ambulance approaches toward you. And when the ambulance is moving away from you, the pitch of the siren lowers. That means there is an increase in the frequency of the siren sound when the ambulance is approaching toward you, and there is a decrease in the frequency of the siren sound or siren, okay, when the ambulance is moving away from you. That means in case of the satellite and the ground station, same thing happens, because the distance between the satellite and the ground station is not a fixed quantity, is not a constant. It is changing continuously because the satellites are revolving around the earth, and the ground stations, those are fixed on the ground of earth. Okay, that means there is a relative motion. Sometimes the satellites are approaching toward the ground stations, and sometimes it is moving away from the ground stations. So whenever the satellites are moving toward the ground stations, in that case there is an increase in the frequency of the signals emitted by the satellites. And when the satellites are moving away from the ground stations, in that case there is a decrease in the frequency of the signals emitted by the satellites. Why this is happening? Because there is a relative motion between the source of the signal and the observer. Observer is here the ground stations, and source of signals are the satellites. So when that means, since frequencies are changing, either increasing or decreasing, that means there is a distortion of the signals. If those distortions are not corrected by adopting any means, then there will be problem in communication. Especially the problem will be in GPS, that is global positioning system. Accurate position of anything cannot be located if there is a change in frequency and that change is not corrected by adopting some other means. Okay, so much problem may be faced by different systems using this GPS. In case of military operations also, the same problem might happen. So there is a need for correction. So two ways are there. One is called adaptive modulation technique, where modulation means what? Modulation means the method by which data is encoded on the carrier signals. So that modulation technique, adaptive modulation, that means that modulation technique is dynamic in nature. Sometimes it becomes faster, sometimes it becomes slower, depending on the shift in the frequency. Means Doppler shift, depending on the Doppler shift. Okay, we are talking about the problem of Doppler shift and how to take care of that Doppler shift here in the case of satellite signals. Okay, so adaptive modulation technique is one of the ways by which you can take care of the signals. Means signals frequencies can be corrected by using this adaptive modulation technique. And one more way is there, which is called Doppler compensation software. Yes, this is the software. This software is built on both the satellites and on the ground station. Okay, and that software predicts the position of the satellites and velocity of the satellites as well. And using those data, the software is able to calculate or is able to predict the change in frequency or shift in Doppler, Doppler shift. That software is able to change, to measure or predict the change in the frequency of the signals emitted by the satellites. That means the software is able to take care of the Doppler shift. Okay, so after prediction, the necessary action is taken by the software. What is the necessary action? The necessary action is to make corrections for the changes in the frequencies of the signals. That is the necessity, and that is the necessary action. So that action is taken care of by that Doppler compensation software. Okay, engineers continuously monitor all these things. Okay, and if there is a problem, there is a distortion, if the correction is not taken, then there is a problem. There will be problem in communication, there will be problem in understanding the correct data sent by the satellites. There may be many more problems associated with changing frequencies of the satellite signals. So requirement was what? Requirement was to take care of the Doppler shift, means to take care of the change in the frequencies of the satellite signal. Okay, so this was all about today's topic. Topic was what? Topic was effect of a Doppler shift in the on the satellite signals. Okay, so this was all about today's topic, and this is now the end of this video. Thank you for watching this video.